In the meantime, though, we are going to continue our look at arithmetic sequences. Okay? So, again, Alex, this is just a real quick recap of what we did yesterday. We started by defining what a sequence is, which is just a list of numbers. We already went over that. The definition of an arithmetic sequence, though, is a sequence where the difference between consecutive terms is constant.
Wait, can I just say what the difference is, either subtraction or addition?
So,
that also count, possibly.
For you, yes, that's fine. I'm just trying to give you the official mathematical definition.
But do we have to write this down?
No, you won't have to regurgitate this on a test or anything like that. You need to understand the concept, though.
Oh, I understand.
So that's fine.
Sequence is a list of numbers, and a arithmetic sequence, I guess you could say, is just the difference in addition or subtraction.
Adding the same number every time for the pattern, or subtracting the same number every time for the pattern. We went through some examples, okay, identifying whether they're arithmetic or not. The labeling here, Alex, is also a little bit different. So clue in here real quick, or tune in real quick. We talk about two different ways to show a sequence. One way is using functions, stuff we've used before. Okay, with the first term, we call that n equals 1, and then f of 1 will be the actual first term. So the number of the term is 1, f of 1 is the first term. Second term is f of 2, again, that's when n is 2. And then if you want to talk about the nth term, that's n, right? Nth term, f of n, right? Or you can use, for the first term, second term, nth term, you can use a sub 1 for the first term, a sub 2 for the second term, and then a sub n for the nth term. That's another way to describe the terms. Okay? So for example, here number 2, it had us just label them. So I had a1, a2, a3, a4, a5, and then f of 1, f of 2, f of 3, f of 4, f of 5. Okay? And then it asked us to find the 13th term. So we figured out the common difference here was 5. And so there's a lot of different ways you can do it. You can just keep adding 5 until you get to the 13th term. That's one way to do it. Okay? But there is a formula. And in fact, we're going to do that formula right now. Okay? So if you flip over to the next page. Okay? The formula, okay, is also known as the explicit rule. The explicit rule. Okay? Now, this has us go through how to prove it, how it shows up here. I am going to talk about that right now. Okay? I guess I was going to think about maybe skipping it, but we'll just do it. Okay? So, if we want to come up with a formula to find any term in a given arithmetic sequence, okay? Well, since we know that arithmetic sequences are linear functions, we can come up with the equation of a line, and that'll be the formula that we use to come up, with any term that we want. Okay? So let's just pick a point here that will be in our pattern. I'll just use 1 for my n, and then that means a sub 1 will be the matching y coordinate. So that's my first point, my first term in my pattern, and that's labeled as a sub 1. So 1 for the x coordinate, and then a sub 1 for the matching y coordinate.
I'm sorry, can you back that up again, please, and tell me how you got 1 and a sub 1?
So the number of the terms n and the term a sub n is an ordered pair.
Oh, okay, never mind, thank you.
Okay, and so that's where we're getting it from. So I could just easily done 2 a sub 2 or 3 a sub 3, so on and so forth, or n a sub n. Okay, the slope, that's how the line is changing. Okay, in an arithmetic sequence, how is the pattern changing? What do we call that thing? How the pattern changes? We call it the what? The slope. That's what we're calling it here. But what do we call an arithmetic sequence? An arithmetic sequence, when that number, how the pattern changes by every time. What do you call that number? Yes, the common difference. Okay? The common difference. Okay? The slope is like the common difference. It's how the pattern changes, right? Okay? What letter do we use to represent common difference? What variable do we use to represent common difference? What was I using on the warm-up? Or not the warm-up, the homework. Not N. Not B. D. Difference. Okay? So the slope will be the common difference of D. Okay? So remember, So we can write the equation in point-slope form. Now remember, point-slope form is y minus y1 equals m times x minus x1. Okay? But what's our point? Well, our point is y minus a sub 1 equals the m, common difference, d, times x minus x1, which is just 1. Okay? Add the a sub 1 over, we have y equals difference times x minus 1 plus a sub 1. Or in function notation, f of x equals d times x minus 1 plus a sub 1. Okay? This is the formula. In, what do we call this? In sequence notation, it would be a sub n equals common difference times n minus 1 plus a sub 1. So that's another way to write it. There's function notation, and then there's the sequence notation. Okay? Guess what?
What?
You don't have to memorize this formula. Okay? You'll be given this formula in a formula sheet.
That's pretty casual.
But you got to know how to use it. Okay? You got to know how to use it. So just being given the formula, that's helpful, but some of us, still need to remember how we're going to use this, right? We all need to remember how to use this. Okay, so let's look at number 3 and how we're going to use this here. So given the arithmetic sequence 6, 10, 14, 18, 22. So given this arithmetic sequence here, okay, we're going to write the equation for the nth term of the sequence. Okay, so here we go. We're going to write the equation for the nth term. Okay, so I'm going to label some of these here. This term, this is the first term, a sub 1, right? And then this is a sub 2, a sub 3, a sub 4, a sub 5, so on and so forth, right? So we're going to use our little formula here. Okay? So let's use this version of the formula. Let's write it in sequence notation. So a sub n equals, well, according to our pattern here, it's arithmetic, so we know there's a common difference. What is the common difference for this pattern here? 4. Times n minus 1 plus, what's the first term? 6. And there's your equation. There's your equation.
And we just do that, like, and then, I don't know, I'm going with it, never mind.
You're not sure where you're going with this? Okay. So what is this formula? This formula allows you to figure out the nth term of the sequence. So for example, let's say we wanted to figure out what the 100th term of the sequence is going to be. Okay? One way you could do it is, start at 22 there and continue to add 4 until you get up to the 100th term. That's one option. Or if we want to find the 100th term here, we would plug in 100 for n and simplify. And that would also give us the 100th term. Okay? So you can do it either way, but of course, obviously, we want to use the formula here. Okay? So, questions on any of this right here, where this came from? Okay? If you don't like that, if that's like weird to you, that formula or whatever, you can also fall back on stuff that we've done in the past. So what I mean by that is 6 is the first term. So that means we could say we have the point 1, 6. The first term is 6, right? And then we could come up with another point, 2, 10. The second term is 10. Well, now we have 2 points, and you can use those 2 points then to write the equation of the line here in slope-intercept form, for example, right? Use the slope formula, 10 minus 6 over 2 minus 1. We get 4 over 1. So we have y equals 4x plus b. And then plug in one of your points and solve for b. We get b equals 2, so y equals 4x plus 2. That's another way to come up with the pattern with an equation for this sequence. This and this are the same. Okay? If you don't believe me, distribute the 4 and then combine the 4 and the 6 together, you'll get a 2. Okay? So these two things are the same. Your choice about how you want to do it there. You can use this arithmetic sequence formula, or you can just, come up with 2 points and write the equation in slope-intercept form here. Okay? So, what are some ways we could come up then for letter B? What are some ways we could find the next 3 terms in that sequence? Let's go to this calculator, man. Tell you what. Dylan. It's pretty much worthless. Dylan, letter B. How can we find the next three terms in the sequence? What's one way we could do it here? We could what? Add 4 to what? Don't wait for me. Answer the question. Nope, you can't pass. Don't help him out either, guys. He's got to think about this. What do you say, Dylan? Add 4 to what? Yes. What's the sequence we're talking about here? 6, 10, 14, 18, 22. If you want to find the next three terms, you've got to keep adding 4. So what's the next term? Dylan, wakey. What's the next term? 26. And then? 30. And then? Okay, perfect. Thank you. All right, it's that easy. Just continue the pattern. Do we have to do it that way? No. We also could have used our formula here, okay? The next term, what is the next term? If I end at the 5th term, the next term will be the, anybody? 6th term. So I could plug in a sub 6. That'll be 4 times 6 minus 1 plus 6. See what I'm doing here? I'm plugging in 6 for the n because that's the number of the term that I want. See, it's a sub 6, the 6th term. 6 minus 1 is 5. 4 times 5 is 20, plus 6 is 20. So, whoops, not plus, equals, is 26. See? There's the next term. Okay? Strategically, whose method is better? Dylan's or mine? Dylan's is better. Dylan's is better. Okay? But what's important to recognize here, is to go to letter C. Whose method is going to be better here? Dylan's or mine?
Dylan's.
All right, you guys go ahead. Do it. Go ahead. Dylan's method. Go ahead. No. Mine's better. Because in order to do Dylan's method, if I want to get the 100th term, that means I need to know the 99th term so I can add 4 to it to get the 100th term. But in order to know the 99th term, I got to know the 98th term, and then add 4 to it to get the 99th, and then add 4 to it to get the 100th. You see the problem? I have to keep going all the way out. Whereas with the formula, I can easily, a sub 100 equals 4 times 100 minus 1 plus 6. I want to find the 100th term, so I'm going to use my formula here that we came up with. Plug in 100 for n. 100, or 4 times 100 minus 1 plus 6. Okay?
105.
So 99 times 4, 400, it won't be 105. It'll be 400 minus 4, 396. So 402, I think, is what that ends up being. Check my math here.
This formula is confusing.
Order of operations. 100 minus 1, 99, times 4.
396.
Thank you. Plus 6, 402.
I like Dylan's better.
Okay, so here's the thing, though. You guys are limited on time. Okay, so Dylan got us up to the, well, let's see, that would be the 6th, that would be the 7th, and that would be the 8th term. So Dylan got us to the 8th term. Dylan has to add, 92 more times here to get up to the 100th term. Okay? Okay? So Sky, what's confusing about the formula here? I mean, what are you having trouble with about the formula, I guess? How to simplify it or how to set it up?
The minus 1.
Why it's there?
Yeah.
I see what you're saying. Because when we're talking about a sequence, the first term of the sequence, we count it as 1. Whereas in a linear equation, the first term we count as 0, as the 0th term. Like the y-intercept is starting when x is 0. Here, for these equations, stuff like that, the first term, it has to like adjust essentially. I don't know if that helps or not. But this is the point 1 comma 6, and so it's not like the y-intercept or anything. Yeah, I'm not sure what it's going to be. I'd say check the Google Classroom tonight. Okay, it'll be posted there. Okay, but it has to do with the fact that with an arithmetic sequence, you're starting with the first term as opposed to linear equations where you normally start with like the y-intercept, which is like really the 0th term. So imagine here, Sky, going back to the 0th term, it would be 2. Right? The 0th term would be 2, and if you look over here, 4x plus 2. There's the y-intercept there. Okay? So that's one way to think about it, maybe, if you prefer. Okay? All right, let's go to this next one here, number 4. All right, Reagan. All right, so Reagan, it's arithmetic, so that means we should have a common difference here. Reagan, what is the common difference? What can you see? What are we doing each time here?
So you go down, right?
Down, by how much?
11.
11. Okay, so our common difference is negative 11. Okay, I'm going to put this up here on the board so you can refer to it. A sub n equals d times n minus 1 plus a sub 1. Okay? So let's fill in our pieces here, Reagan. A sub n equals, what's our common difference? You just said it. Negative 11 times n minus 1 plus, what's our first term? 17. That's it. That's the equation right there. Okay. If you want to use function notation, you could easily just say f of x equals negative 11 times x minus 1 plus 17. If you don't like the whole n thing, okay, you can just use x's instead. Or you can use n's. We could say f of n equals negative 11 times n minus 1 plus 17. These all three things are saying the same thing. Okay. Let's find the next 3 terms in the pattern. Kendall, what are the next 3 terms in the pattern here, Kendall? You still writing? Okay, gotcha. All right. Next 3 terms. After negative 27, it's going to be?
Negative 38.
Okay, Sky's got that one for you. Kendall, you get the next 2. What's next?
This is easy.
Negative 49.
Shh, maybe Kendall wasn't paying attention. Kendall, what's the common difference here? What do we do each time?
Subtract 11.
Kendall, please, Sky. Yes, subtract 11. So, Kendall, when we wanted to get the next term after negative 27, subtract 11, you get negative 38. So the next one will be negative 49. And the next one? Negative 60. Thank you, Kendall. Okay? There it is. Sky, thank you for your help, but we'll make sure everyone gets a chance here to help out and answer too. All right. All right. Next, we're going to do the 75th term. Okay. So that's 75. We're going to plug it into our formula. Simon, where does it go in our formula here?
The 75th.
Uh-huh.
It goes in the n.
N, and we're going to put in 75, right? The number 75. So negative 11 times 75 minus 1 plus 17. Okay. Simplify. You can use your calculators. Okay, I get negative 797. Okay. Do not sit here and think you're going to use Dylan's method and go all the way out to the 75th term. Okay? And sorry, Dylan, I know it's not really your method, okay, but don't do that because you are going to take way too much time to do something like that. And there's a chance for you to make a mistake, too. You need to be comfortable with using this formula. Do you have to memorize the formula? No, but you need to know how to use it. Okay? Shall we move on? Okay.
I got you.
Question, Liv. Question?
You got this.
Well, Liv, please. It'll be helpful sometimes. You don't know. Negative 49, you want to subtract 11, and you get to negative 60. Yes. The common difference, negative 11. Oh, sorry. You guys are still looking at something there. Okay. No. Hold on for this next one here first, and then I'll let you go. All right, hold on for the next one, and then I'll let you go.
Are we on 5?
Number 5. Next page, number 5. Hold up. Guys, look, you need to try and follow along with Mr. Widmeyer as we're writing. it shouldn't be not pay attention and then start paying attention once we're going to turn the page here, okay? Make sure you're following along. All right? Okay, again, I put on the board here for you the explicit formula. Okay? So, take a look at number 5. And let's see what we can come up with here. I'm going to go to someone here.
I'll do it.
So, let me call on someone around here. Matt T. Matt T. What's going to be our formula here we're going to set up? We'll worry about this blank filling in just a second. Let's do it right here first. What will be our formula we're going to write here? A sub n equals negative -50. Okay, parenthesis. N minus 1 plus 150, that first term there. Yep, okay, exactly right. Or in function notation, f of n equals -50 times n minus 1 plus 150. Now look down here. It's got some blanks. It's got a blank in front of an n and then just one other blank. So in order to be able to fill this in order to fill in these two blanks here, what do I need to do up here?
You have to solve for n.
We got to
You have to find n.
yeah, we have to like do some simplification here essentially. So what can I do up here to simplify this sum? What can we do mathematically here to simplify this sum?
You could multiply -50 times -1.
So distribute -50 times the n and the -1 here. We get -50n plus 50 and then the plus 150 as well. Okay? How can we further simplify? Add the 50 and the 150. You got it. -50n plus 50 and 150 is 200. And now you can see we match the format right down here. So -50n plus 200. Okay. Is this different than this? Is this function different than this function? No, they look different, but the actual relationship they're describing is the same. Okay? So yes, they look a little different, but the relationship they're describing is still that arithmetic sequence. So this is the same as this. Do you have to simplify? No. If you don't want to simplify this, if you want to use it from here, you can. If you want to distribute the -50, like Sean suggested we do, and then combine terms, then you can do that too. Okay? That's okay. If you want to simplify it first and then do your math, your choice. Okay? All right. I want to do... All right, you can go to the bathroom now, Mark, if you want to. Okay. Guys, look. I know it's all fun and games, but this bathroom stuff, I mean, you guys are missing out on educational time right now. The bathroom should really be for an emergency situation. Please try and go during lunch, okay? This happens every day, and I get it. If you really got to go, you got to go. I get it. You get on a schedule and stuff like that. Try and take care of it during lunch if you can, because when you're not here, you're not learning, okay?
Mr. Whitmore, do you think the set should be longer?
No.
You think it's long enough?
I think it's long enough.
TJ's an hour long.
Right, but that's because it includes their lunch, too.
Yeah.
So,
They have like 5.
Lanny starts an exercise program. Okay. Lanny starts an exercise program.
I can pay $75.
Here we go, folks. Lanny starts an exercise program. Her trainer suggests 10 minutes of weightlifting the first week and to increase the weightlifting time by 2 minutes each week thereafter. So, is this going to be arithmetic?
Yes,
How can you tell?
because it is +2 and it doesn't change.
We're increasing by 2 every time. We're not changing how much we're going up by. We're increasing by 2 every time. That's right. Exactly right. So, if this is going to be arithmetic, what's going to be our first term here? Hannah, what's the first term?
10.
10. Yeah. So, a sub 1 equals 10. Okay. First term is 10 minutes. And then what's our common difference? Let's go to Dylan. Dylan, what's the common difference here?
The common difference.
What are we going to add or subtract by each time? Need help? 2 minutes. That's right. D equals, and it's positive 2. We're going up by 2 every time. Okay? So there's enough information. Let's go ahead and write that equation. So Someone we haven't heard from yet. Let's go to Sean. Sean, what's our equation going to be then?
It's gonna be,
A sub n equals.
it's gonna be, yes, equals, oh, wait, hold up. Wait, hold up.
Look at the board.
Yes, a sub n equals,
2 n minus 1 plus
10.
10. There you go. Okay? Or if you like function notation, because it does say function notation, so I should really write it f of n equals 2 times n minus 1 plus 10 there. Sorry, I should have written it that way, because that's function notation using the f with the parentheses and stuff like that. Okay? The trainer believes an optimal goal is an exercise program. Wait a minute. The trainer believes an optimal goal in an exercise program is to spend 30 minutes weightlifting. During which week will Lanny reach this goal? Okay, so where can I plug that 30? Should that go in for n? No. We set our function equal to 30. So it'll be 30 equals 2 times n minus 1 plus 10. Okay? We want to figure out how many weeks will she reach that 30-minute weightlifting kind of thing. So 30 goes in for f of n. Okay? And now we'll solve. Okay? How do we solve this? Caden, what would we do here to solve this equation? Subtract 10 both sides. Okay? So we get 20 equals 2 parentheses n minus 1. And then? There's a couple ways you could go here, so. Okay, Caden says distribute. Did anyone think to divide here? All right, Scott, you want to go? Yeah. Okay, so 20 equals 2n minus 2. And then, Caden, what should we do from here? Add 2. And so we get 22 equals 2n. And then finally, divide both sides by 2. N equals 11. So after how many weeks will Lanny reach this goal? 11 weeks. 11 weeks. Okay? All right, we're going to skip this next one because that graph is hard to read. So we're going to skip it.
I can see it.
You can see it? I don't know, the x-axis,
Yeah, I can't see it.
I'm not sure about that x-axis.
I skip it.
The y-axis I can read, I think. Even then, I'm not even sure. Yeah, we'll skip that one. That graph is too much. Oh, sorry.
Why don't we just not do
You're
it?
so sad.
I can't see that part of
Oh boy, a new rule.
That's right.
So right. When's the test?
Thursday.
I might need to come into set time.
I'll push you in.
Thank you.
You're welcome. All right, folks. Next page here, we're going to look at a different way to think about patterns. And this is actually what I would call what Dylan was doing. Okay? And this is what you guys learned way back when you first, started talking about patterns in your life. Okay? The way you always described a pattern when you first learned about patterns, okay, was not to come with a formula. Formula was later. Okay? What you did is you just found out how things were changing, right? And then you would just then continue the pattern. Okay? You would take the previous term and then use that to find the next term. Right? That's what we did on the very front page here. Well, something that's arithmetic. Let's go to, they didn't give us very nice easy ones, did they? Well, right here, for example. We're adding by 5 every time, okay? Dylan is easily able to find the next term. He just adds 5. And then if he wants to find the next term, he adds 5 to that, so on and so forth, okay? But the weakness of Dylan's strategy that he was using, and the weakness of that strategy, is that to find the next term, you need the previous term.
Okay, dude. What?
Okay? So Sean, that actually attaches to the back of your calculator. You can slide it, and so it won't fall off anymore, okay? What's that? Potentially, you might want to keep it out, just in case, okay, for arithmetic and stuff like that, okay? But yes, I would encourage you to at least slide the back on your calculator, since it's happened to fall twice now. Okay. What that is, when you need the previous term to find the next term, that is called a recursive formula, recursive definition. Okay? So, given a starting value called f of 1, the next term is found using some recurring pattern. See, recurring, recursive, okay, right? If the pattern is arithmetic, then the recurring pattern is to add the common difference d. Okay? So, given f of 1 equals blank, right, some number, whatever your starting term is, okay, then f of n will be equal to f of n minus 1 plus d. So, the next term will be equal to the previous term plus the common difference, okay, for n greater than or equal to 2 there. Okay? And that's just one way to write it. Okay, there's other ways too. For example, you know, we could say if a sub 1 is equal to, you know, and let's just say hypothetically here, a sub 1 is 1, okay, then I could say that a sub n is equal to a sub n minus 1 plus my common difference, whatever that happens to be. Okay, that is a recursive formula because I need the previous term to find the next term. Okay, I need the previous term to find the next term. But a similar way to write this, I could write, again, a sub 1 equals 1. I could say a sub n plus 1 would be equal to a sub n plus the common difference. You see there, I'm still finding the next term. Here in this case, I'm using the previous term, adding the common difference, and I find a sub n. Here I'm finding a sub n, I add the common difference, and now I get a sub n plus 1, the next term. Okay? So these are all recursively defined formulas. So let's see this actually in practice here. So given the arithmetic sequence, f of 1 equals 18, and f of n equals f of n minus 1 plus 6, write the next 6 terms. Okay? So this is, again, a recursive definition. It has a term and then the previous term plus that common difference there. Okay? Whoops, I kind of gave that away too. Okay? What is the amount that we're going to be adding each time here? 6, right? Plus 6. Right? We're adding by 6 each time. All right, so let's go to f of 2. Okay? So using this formula here, if I want to find f of 2, that's going to equal f of 2 minus 1 plus 6. Right? F of n is 2. So 2 minus 1 plus 6 there. You see that formula? I plugged in 2 for n.
So wait. F of n minus 1 plus d.
The common difference here is 6. We're adding 6.
So the next 6 terms. Oh, plus 6. I'm sorry. I didn't see that plus 6 in the 6 terms.
So we're plus 6, and then, yeah, this next 6 terms, and that's what this is doing right here. You can see 1, 2, 3, 4, 5. Well, 1, 2, 3, 4, 5, 6, like this. Okay? So, what is 2 minus 1 simplified to be? 1. Okay? What was f of 1 according to our directions here? What was 1? F of 1? 18. 18 plus 6? 24. Okay? So f of 2 equals 24. Or in other words, the second term is 24. The first term is 18. The second term is 24. You guys already know what's the third term going to be then? 30, right? How'd you get that, Sky? What'd you do? Added what?
6.
Yeah, sorry, added 6. Exactly right. Okay? So the next term here, f of 3, that's going to be 30. Okay? Let me show you with the pattern, though, too, with the recursive pattern. F of 3 will equal f of 3 minus 1 plus 6. Or again, we're going to find the next term by using the previous term and adding 6. 3 minus 1 is 2. F of 2, we know it from right here. F of 2 is 24. So we'll do 24 plus 6 like Sky just did, and it's 30. Okay? What's the next term going to be? Let's go to Ella. If the third term was 30, what's the fourth term going to be then? Yeah, 36. You got it. We can just keep adding 6 here. The fifth term, what's that going to be? Let's go to, what's that? 42. You get it, right? We're just adding 6 every time. Add another 6, 48. Add another 6, 54. Okay? This recursive pattern is just showing what we're doing here. We're taking the f of 2 to find that second term. We then find f of 1, really, and then add 6 to it, right? To find f of 3, we find f of 2, or we use f of 2 and add 6 to it. F of 4 is really f of 3 plus 6, right? In this case, f of 5 is really f of 4 plus 6. Right? That's all we're doing here. It's not that crazy. Okay? So that part's easy, coming up with a sequence. But let's move on one more thing here. One more problem. Okay? To number 2. Okay? One more thing here to number 2. Okay? Here we're given some information. First term is negative 6, second term is negative 11, third term is negative 16, fourth term is negative 21. And we're going to construct the arithmetic recursive formula. Okay? So first we have to say what the first term is. Okay? So Kendall, what's the first term here according to our information? Negative 6? Yeah, no questions there. Okay? The next term is equal to the previous term plus, and what are we supposed to add in a arithmetic sequence? What do we add or subtract every time? What's that called? The common difference. What's our common difference here? Positive 5 or negative 5? Yeah, negative 6 minus 5, minus 5, minus 5. So the common difference here is negative 5. So this is the recursive formula right here. You have to give where you start, that first term, and then how to get the next terms. Okay? Previous term plus negative 5 gives you the next term. Okay? Go ahead and try number 3. Finally getting you one to try on your own here. Try number 3. Okay? Construct the recursive formula here. Okay? I'll give you like 30 seconds. That's all you, what's that?
I said I already know what it is.
That's what I'm saying. It shouldn't even take 30 seconds, but I'm being generous. Yeah, I'm gonna tell you what it's gonna be here in just a second. But this will be our last one, and then we'll do that. Okay? Crikey. Okay, time's up. Let's go to Tyler C. Tyler C. F of 1. What is it?
We're doing like this one or this one?
Number 3.
Oh, I know. Okay. Well, let's see. Let's break this down. 8. What?
8 is the common difference. F of 1 means the first term. First term.
Oh, 10.
10.
Got it.
And then over here, what goes here?
8.
Plus 8 every time. That's right. Okay?
Got it.
Got him. Okay? So, your assignment. Get that paper out from last night, please. Paper out from last night.
Are we doing the even?
So, no, what I'm going to have you do... I'm going to have you do 11, 13. Okay, 11, 13. Turn the paper over. And then 19, 21. Okay, so 11, 13, 19, and 21. And then actually I might have you, let's see here. Number 4, just number 4, please. Number 4 from the notes. Number 4 from the notes. The next page there.
Actually, which ones are we doing on like this paper?
Number 4, yes, A, B, and C. And then 11, 13 here, and 19 and 21. Okay, so I'll put that up here on the board. Okay.
I need the paper for
last night? Okay, number 4 from notes. And then number 11, 13, 19, 21 from homework. Okay, that's your homework right there.
Wait, Mr. Wimar.
Go ahead.
Okay, this is just going on by negative 14.
Negative 14, look at what it says. Negative 14 is a sub 1. That means that is your first term. You start at negative 14, and then
you get another negative 14.
how's it changing?
And then you
Negative
subtract 5.
Minus 5. To get the next term, you take that term, the previous term, and subtract 5. So you're subtracting 5 this time.
Thank you.
That's your pattern. All right, sorry, I'm getting you started. It's very easy. Just identify whether it's arithmetic or not. I would like you to.
So which one was it?
Yes, you may. You're not.
Wait, what's the explicit formula?
That was last night.
Explicit?
Explicit. Can you tell me?
Explicit means the formula, like we were coming up with before with this right here. This is the explicit formula right here.
Don't we have them on the board or no?
You will be given this formula anytime you need it for a quiz or a test. You won't have to memorize it, but you need to know how to use it. That's the
And we
explicit
have to
formula.
fill in the D and the A, correct?
You need to fill in the D, common difference, and then the first term, and then use that to help you find the difference. And 11, 13. But in 11, 13, you're given the explicit formula, Alex. And then 19, 21. In 19 and 21, it's where you have to come up with the formula. Yeah, make sure you read the directions, folks, about what you're supposed to be doing.